Greetings, I'm Jed, and today we're going to talk about additive manufacturing machines, known as AMMs. You may ask, for which purpose do we want to extend their lifespan? Sustainability. We must ensure our children's needs while making more efficient products. As of today, the market is on the rise. They allow rapid prototyping and consumer-ready product creations. Around 3,000 tons of filaments were used in the UK in 2022, and the market is set to grow 400% in the next 5 years. However, as useful as they generate a gargantuan amount of waste. The explanation? Those machines are inefficient and not sustainable. Indeed, its components are energy hungry, space wasting, and vulnerable to planned obsolescence. We suggest 4 ways to counteract against those flaws. Reuse stepper motors. A stepper motor can last for years. The motor sends an electrical pulsation to the motor collie, creating magnetic field, forcing it to move slowly along the printer axis for accurate printing. Hence, they have low stress exposure, making them easy to reuse. Nonetheless, only 12% of motors are recycled with 10,000 hour lifestyle. Reusing this material can reduce CO2 emissions by half compared to making new ones, as fewer raw material would be used. For example, dysprosium, which is used for heatproofing, has less than 10% recycling rate, so less waste would be in landfills. Recycle LCD screens. Indeed, the market is established, and corporations earn profits by recycling wasted LCD panels. Furthermore, we can refer to Figure 5, all raw material constituting LCD screens. To understand the task complexity, those companies, through meticulous and manual dismantling, recycle a variety of material. For example, plastic is sent to shredders for further recycling. Valuable parts such as PMMA boards are stocked waiting on recovery. Lamps are processed through mercury recovery. For 1 ton of LCD panel, 825 kg of glass is retrieved, and REVs such as indium and palladium are recovered with a 96% success rate. Thanks to this method, we can lower the 6 million metric tons of electronic waste and CO2. Reduce. Power supply unit. The power supply unit, PSU, converts AC from a wall outlet into DC needed by computer components. Nevertheless, to enhance this process, we need a smaller PSU. For example, the Ender 3D uses a 60 by 60 by 20 cooling fan. Nonetheless, on the market, there are smaller fans which are similar in terms of energy efficiency while requiring 20 to 40% less power. In this case, we chose a 40 by 40 by 12 millimeter fan to replace it, achieving 33% size reduction. To enhance performance, users can add storage output capacitors, but only 2 of the 5 available slots are usually used. So, removing 2 of them will result in an additional space of 5 millimeters. So, at the end, we have a reduction of the area of PSU by 23% and a 23% reduction for aluminum usage of the PSU case. Dispose micro SD slots. Micro SD cards are less present in our daily work. Indeed, only certain industries use micro SDs in their operation, as people moved toward Wi-Fi as it had a longer lifespan. However, they are still present and have a product footprint of 530 grams per CO2 per unit. 50% of it just on electricity, and 30% on PPCs. Removing 3D printers micro SD slots would allow to save a lot of in-demand metals such as silicon, copper, and gold, hence lowering the estimated 530,000 tons of greenhouse gases released. In conclusion, reusing ensures extending the lifestyle of motors while making an ecological and economical impact. Reducing allows less energy and material to be wasted while improving on quality. Recycling allows products to be part of a new sustainable chain, and disposal allows us to go towards cleaner technologies. Here are my sources. Thank you very much for listening to me.